Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to review some thoughts about the distributive property. Now, the distributive property states that we can distribute multiplication over addition. And so with symbols, we write A times the quantity B plus C equals A times B plus A times C. You have seen this earlier. It also applies with subtraction. So let me write it. A times the quantity B minus C equals AB minus AC. Why does it also apply with subtraction? Because any addition can be changed into subtraction. Any addition is the subtraction of the opposite number. Okay, let's go on, and here's a bunch of practice exercises. We're going to simplify all of these expressions using the distributive property, but try them first yourself. Pause the video and work on them, okay? Here in this first one, we need to take this -3 through the parentheses, multiply each term here inside parentheses by it. So -3 times 2x. If I write it out in full, it is like this. Then plus is a plus -3 times 5. But this simplifies. We will get -6x and then plus minus, okay, this becomes -15, but I can write it as subtract 15 instead of add -15. The next one is almost the same. So what will be different? There's a subtraction here. So what happens? We get just like before, -3 times 2x. Then is the subtraction, and then that -3 times 5. So here this would be -15 again, but since there's another negative, it becomes plus. It becomes an addition of 15. As you work on these, you can start then developing shortcuts and work through them faster. So here, when I have -6 times a, okay, that's -6a. Then this -6 multiplies this one too, but I see a subtraction, so I know that the negative and negative will turn it ultimately into a plus sign. So I just write it there, and 6 times 2b is 12b. And then -6 times 7, we get -42, or subtract 42. Here, negative times negative is going to be +30x. Then negative times positive is going to be negative. 10 times 2, it's going to be 20, and y. And then 10 times 5 is 50, and negative, so it's going to be +50. That is what I mean, that we can omit the intermediate step, thinking through these negatives and positives in our heads. And then here, okay, there's no actual number here, it looks like. There's just a negative sign, and then the quantity in parentheses. But you can think of it there as being -1. If that helps you. So what happens is -1 times this, and -1 times that, and -1 times that. So in the end, each one of these terms just changes signs. We get -15a plus 7y minus 4, because each term got multiplied by -1. Next exercise. Is this correct? Try to solve it yourself first. Let's check. Was this simplified correctly? We have 2y, yes. 2 times -x, yes, -2x. 2 times 5, 5. Nope, it should be 10. So yes, there was a small error. Let's also look at an expression that has a fraction. As we use the distributive property, it works the same. Let me write out it in full. We have -2/5 times this first term, which is -10y, plus the -2/5 times 8. Here, negative times negative, so it will be positive. As an intermediate step, we would have 2/5 times 10y. Here, this will be negative plus minus, okay, it turns into a subtraction in the end, 2/5 times 8. Here we can go 2 times 10 divided by 5, which is 4. The other way would be to cancel like this. Again, leaving 4. Here, 2 times 8 is 16 over 5. And that doesn't simplify. Well, you could say that I could write this as a mixed number. That is true. You could write it as 3 1/5. But in algebra, we tend to avoid using mixed numbers because they are easily confused with multiplication. For example, it could be confused with 3 times 1/5. Or if you write 2 1/5, if you write it just a little bit sloppy, it could look like 21 over 5. So that is the reason that we prefer fractions over mixed numbers. Let's try now one with decimals. Here we have a quantity multiplied by 20. So let me write it the usual way, where we have the number we multiply by here in the front. And now, as usual, 20 times this number. 20 times 4 is 80, but it has 1 decimal digit, so it's gonna become 8, and negative 8 at that. And then 20 times 1/10 is 2. Now, factoring means using the distributive property backwards. It means that for each term here, we try to find a common factor and then pull it up front, so to speak. Here, each number is divisible by 7, so I can write this as 7 times, and then something in parentheses. Okay, this one has to be negative 2x, right? So that we get negative 14x when we multiply. Then 7 times 3y, and then 7 times just 5. We could also write it with negative 7 here as the multiplier, in which case then everything else changes signs. And you might think that this looks neater. I don't know. Both are correct. Here's one where we can factor using a fraction. Since there's 3/4 and 1/4, we could put 1/4 here. And 1/4 times what? Well, negative 3 and x. 1/4 times what would give us, okay, you have to think of here being as 1. 1 times y. And so 4 times 1/4 would give us the 1, but it's negative. And then lastly, 1/4 times 1. Again, since we see negatives here, we could alternatively write it with negative 1/4 and then change the sign of everything. Okay, this is all. I hope it was helpful.